All right, I guess we're ready to get going here. My name's Paul, and I'm here to talk about the Elixir ecosystem. I'm currently a senior full-stack engineer at ThoroughCare, and at ThoroughCare we specialize in Rails and Vue.js, but here I'm going to talk about the Elixir ecosystem. Part of the reason being, I discovered it back in 2015, just after it was a few years old, and if I look at web development objectively, I can't really find another stack that operates as well or as efficiently as what the Elixir ecosystem has to offer. So I was just going to go over it, go through some of it. All right, so Elixir all starts with Erlang. It's been referred to a lot of times in the past that Elixir is just standing on the shoulders of giants, which truly that's what it is, because really it's all about Erlang, and that's where everything's coming from. So Erlang, it's built for concurrency and fault tolerance. It's built on processes. It was originally designed for the telecommunications industry, telephone switches, things of that nature, where you need a high throughput and high concurrency. So that's the problem it solves. Distributed, it's very, distributed architecture. This is first-class stuff for Erlang and the Erlang ecosystem. This is what its focus is, and this is what it's built for. And it's been doing it since the 80s, decades. Beyond battle-proven, very, very capable. One of the things is the Erlang VM itself. So the Erlang VM, you could kind of think about it as like the JVM. It's the virtual machine, referred to as Beam. So basically what this is going to do is running an application like, say, on your laptop, you're going to get an Erlang VM instance, which is going to be a thread running on your computer. So this is going to be responsible for making concurrency and fault tolerance happen that the system supports. Everything is built around small processes that are very lightweight and very inexpensive to run. So what's going to happen is this Erlang process running on a computer is going to allow all these processes to run and be able to work concurrently across all the cores of the CPU. So the way it does this is when the Erlang VM thread starts up, it creates what's called a scheduler for every core of the CPU. If you have 8 cores, you have 8 schedulers, 12 cores, 12 schedulers. This particular laptop, I have 12 cores. I have 12 schedulers when I run the Erlang VM on my machine because it automatically has a schedule on every single core. So what these schedulers do is they use preemptive scheduling, and they have a queue of work to do, and they do them in a time slice. Time slice is basically defined, I think, by the architecture of the processor, some weird detail like that I don't know. But anyways, it has a time slice, and there's a queue of the work coming that needs to be processed. And it gets spread out across all the cores, and it does this concurrently in a parallel processing to be able to achieve a high concurrency throughput through the virtual machine for your application. Now, the other thing it'll do will also load balance. So you have all this work happening across all these cores, but the Erlang VM is going to load balance it as well. So you don't have cores being overloaded and cores not doing anything. Spread the work out evenly. And the best part is this is all automatic. You don't even have to think about it. Erlang VM takes care of all of it. There are options and things you could do to adjust how it operates, things of that nature. But by default, you don't have to do anything. This is just free, and it's been doing it for decades. It's beyond battle proven, so it just really performs well, and it's just an incredible piece of software. And when I first heard about it, it's like, why would I not want to use this? Compared to everything else I've used, I started with Rails in like 2006. I've done it on and off through my whole career. I've done Java, Enterprise Java, C#, VB.NET. I've experimented with at least another 10 or 15 languages. And for web development, I really haven't found anything that really can do what this does. So it's pretty incredible stuff. So it all starts with Erlang. Elixir. So this is just a modern dynamic functional language that runs on an Erlang virtual machine. Dynamic typing, flexible and expressive code that emphasizes immutability. The only word in here that's bolded is the word immutability. And when I was showing this to my wife last night, she said, "Why is that the only word that's bolded in this whole thing?" I was like, because it's that big of a deal to me. So immutability, right? Elixir, the data is immutable, and that's a big deal, and it's extremely important. It's extremely important to functional programming. It's extremely important to write efficient code. And one of the things that I've noticed in our industry is there's always platforms doing OOP and functional all at the same time. Or, you know, we're OOP, but we do some functional, kind of mix and match, and that's fine, that's no problem. But when it comes to immutability, it's a different game. If your basis is an immutability, if the standard for the language is not immutability, it's a little bit of apple oranges. Yeah, you get people say, yeah, we do some functional stuff. Yeah, we got currying or functors or, you know, that stuff. Honestly, I've been around Elixir since 2015. I've never heard anybody talk about functors and currying. It's about the immutability. If you start with immutability, everything about your application changes. The way you solve problems, the way you build your applications, eliminating all of the bugs that are caused by state that's mutated all goes away. And immutability is just the gold standard. And one of the reasons why I feel very vindicated about this is I actually heard Jose Valim, the creator of Elixir, in a couple interviews recently where he was talking about what matters to him when it comes to functional is immutability. The rest of it, to me, is pretty much optional. But coming from immutability and focusing on immutability makes a big difference. So even if you work in a platform that might be a combination of object-oriented and functional type techniques, try something that's just immutable, whether it's this or Clojure or whatever, because it'll completely change the way you solve problems. So, you know, immutability is a really big deal. But again, you know, metaprogramming, you know, it's common these days. Scalable, maintainable, again, it all comes from Erlang, standing on the shoulders of giants. So they get all of that for free. All right, Ecto. Ecto is the data layer within the Elixir ecosystem, like kind of based on a repository pattern. It's made up of four components, four main ideas. One, the repo, where the data is. Basically, this is just how you interface with the actual database. When you need to actually communicate with the database, it's done with the repo module. Schema, what the data is. This maps the data into structs in Elixir. So the main, kind of the bread and butter data structure is map. It's just a key value pair, it's a map. A struct is basically a map with an extra key in it. There's nothing special about it, other than it has this name associated with it. And it's just key value pairs. So what this schema allows you to do is to map that data into structs. So you create this module, it defines this schema, but the interesting thing is you can make that schema look like anything you want. You can have a very large table with 40 rows on it, but you could have a schema that's just taking 10 rows of that, it only cares about 10 rows of that, and you have a struct that just represents a subset of that data. Or you could go the other way and say, you have this schema that represents this data table for your database, but yet you're gonna add 5 more fields to it, or some kind of virtual values or something else you want added to it that aren't strictly in the database as data, and you could represent it as if you're interfacing with a data object that's in a database transparently. You don't even need to have a data table behind it. You can do what's called embedded schemas. You don't even have to have that. So it's flexible. Yeah, and that's one of the things it's focused on. It's a simple language. It's all about being clear. It's all about being explicit. And it's all about keeping things flexible. Ecto query. Queries, composable, secure queries in Elixir. Very easy to work with, very SQL-like. They're not exactly SQL, but they're not that much different than SQL. If you look at it, you can easily see how close it is to SQL and how close it represents an actual SQL statement. Very easy to work with. Change set, which really is, to me, one of the most interesting parts. So this is how you track all the changes to data. So whether you're gonna, insert, update, all those things, destroy, this is where you track and validate everything. And the best part is it's an explicit process. You have these change set functions. You could easily add any kind of validation, custom validation, everything's explicit, straightforward. Everything is right there, there's no hidden secrets. And it makes it just very easy to work with. I've worked on projects where we would have multiple change sets within a schema depending on what we were doing with that particular data. So it's a very flexible, very powerful concept. And that's kind of what the Ecto library is about, and really Elixir altogether. It's how can we be explicit, how can we be flexible, how can we be powerful at the same time? So that's kind of what they're always striving for. And everything within this ecosystem, that's kind of the goal. So that's Ecto. Phoenix. Most people know Phoenix, I'm sure. There's nobody here that doesn't know Phoenix. Has everybody heard of the Phoenix framework, or mostly? Probably. No? Okay, maybe not. All right, so Phoenix Web Framework is the basically batteries included Rails-like framework for the Elixir ecosystem. Jose Valim, the creator of Elixir, was on the Ruby on Rails core team for a while. So there's a lot of inspiration, direct inspiration from Ruby in here. So like if you look at Elixir syntax, it's very heavily influenced by Ruby syntax. If you look at the Phoenix framework, it's very heavily influenced by the Rails framework. Very modern, MVC, everything you expect to see. It's got generators, it got migrations. There's nothing really missing when you're talking about a full stack modern web development. It's all there. Channels. The reason this framework was really created was basically soft real-time communication. A lot of that comes down to channels and WebSockets. So you could do things like a live chat, notifications, real-time updates. That's kind of the basis of why Phoenix was created in the first place. Live View. This is another fantastic piece. This just reached 1.0 a few months ago, and it's all server-side rendering. The goal was to minimize how much JavaScript had to be written in an application. How could we get away with doing server-side rendering and eliminate as much JavaScript as possible? And that's what Live View represents. But the most interesting part is different than how JavaScript works. What this will do is, instead of doing full page refreshes when state and data change, what this will do is there will be an initial mount of a template into the web browser, but state changes are a dynamic update, a diff of just what's changing. So you're not re-rendering pages, you're just sending back what changed and updating those values on the template. So you're not reloading pages, not rendering pages. You only do that once, and that saves a lot of time, makes it very efficient. I recently was working on a application out of Elixir Phoenix and had a front end that was Next.js, and I decided to consolidate into a single stack, so get rid of the Next.js app and put it all in Live View, and I pretty much rewrote the whole Next.js app in like 4 days. I mean, it was pretty simple. It really wasn't a whole lot to it. It was that easy, and it's just a modern technique, and it's not that much different. It's a very easy thing to do, and it was much faster because now I eliminated all the API calls. I didn't have all this latency and traffic going back and forth between the front end and back end. It was all just right there. And I mean, it was really good. It worked out really well. So Live View, that's another fantastic piece. But this one is probably my favorite, Oben. Oben is a background job processing library for Elixir. It does what you would expect any job processing library to do. Scheduling, retries, queues, you could adjust concurrency of queues, everything you expect from a job processing library, concurrent and reliable. Interesting thing about Oben is everything is stored in a Postgres database. So what you do is, there's 2 tables added to the Postgres database, and it'll manage all of the jobs through that. And you don't have to worry about tables getting overbloated because it'll prune all the old data out when jobs are completed. Data gets pruned out, and it's very efficient. It's been benchmarked at 1 million jobs a minute. Do we need 1 million jobs a minute? No, most likely not. But if I can achieve that kind of performance, I don't have to mess with anything for a year or 2 down the road. So very efficient. Apsiv, GraphQL library, official specification adheres to real-time subscriptions. It's optimized for performance. You could do things like batching and query depth limiting to limit GraphQL queries, machine learning. So this has been another big piece recently in the Elixir world. A live book, basically like Jupyter Notebook, very modern, very nice. NX, high performance numerical computing, Axon for neural networks, Scholar for traditional machine learning tasks, and Explorer for data manipulation and data frames. This is more of a recent thing, and this is still in its early stages, but it's a really growing area, and it's really gaining a lot of traction. Again, because of the concurrency and the power that the language and Erlang VM offer, it helps make things like that even that much more efficient. Python is hard to compete with, right? It runs the whole entire data science world and all machine learning world, but I just recently found out that you could actually embed now Python into the machine learning live books in Elixir. So that might offer some more flexibility and options down the road. And yeah, that's about it. So yeah, that's it.